now I will explain you how to do the measurements. Our first intention is to see the influence of the flow on the pressure loss. So what I am going to do here is, if you take your lab handout and then if you go to the performance measurements, you will find the first table here, measurement of pressure drop in the bed height, measurement of pressure drop and bed height. So in these first three columns you have the airflow defined by us for the different conditions. So first of all, you need to have the airflow of 0.5 cubic meter per hour. So to get that, what you are supposed to do is, you set the flow when you read 12.5% percentage reading on the meter 1, because these two rotometers are scaled as a percentages. So they are calibrated before, and so when you want to get this 0.5 cubic meter per hour flow rate, that is corresponding to the 12.5% percentage of the rotometer 1. So what I am going to do here now is, I am reducing the power, because when I am reducing the flow, so I do not want to overheat my heater. So I just reduce the power first, and then I am reducing the flow now to get the first reading, which is 12.5 percentage of the rotometer 1. That setting is corresponding to 0.5 cubic meter per hour. So when I am at that situation, you can see that the bed is almost stand still, and now I need to measure the pressure. So the pressure taps are already inside. So these two pressure taps are giving the pressure drop across the bed itself, which is corresponding to the difference of these two water columns. It's about 70 millimeter minus 30. This is like a 40 millimeter the water column pressure difference. So when I take this reading, so I can fill it here, the pressure drop millimeter, the water vapor, water on the sand bed here. And then the next step, so I take this off and then close the hole by hand, and then I take the pressure difference again, and then I can fill it on the fourth column, where I get the pressure drop across the sand bed plus top filter. So I have the readings of pressure drop and the top filter here and the sand bed itself here. So then by subtracting this value from here, so I get the pressure drop across the top filter, and then similarly I go to the second level by increasing the flow to 25%, which is corresponding to 1 cubic meter per hour. And now you can see some the fluctuations in the bed, and then I take the pressure drop readings as I did in the first case. So I go through all these values, and then I fill this table, and then I plot the graph of the pressure drop against the flow. Then you will see how the performance looks like.